join the webinar, and please just a moment and we'll go with our program. But I can meanwhile say the overall plan of it is going to be 2 longer talks and 3 shorter talks, also known as lightning talks. So we're going to announce them really shortly. Nope. Yes. Good. Thank you, back team. Please keep those open, and we can use them for questioning and answering. So the first one is called Listening to the Noise, Understanding Quick Deployments Using Passive Measurements. It's Jonas Mücke from Freie Universität Berlin. I hope I said his school name correctly, and please go. Thank you. We have a timer for you.
Okay, hello everyone, good morning, I'm Jonas. I'm a PhD student at technical universities, so I recently changed universities, and today I'm going to present you our joint work on using passive measurement data to analyze quick deployments. We have talked about QUIC in this conference before, but I still quickly want to introduce you a little bit to the protocol. So QUIC is a new transport protocol. It is based on an existing transport protocol. It's based on UDP. So any features that you're used to from TCP, you will have to implement now in QUIC because UDP does not come with it. And additionally, QUIC gives you encryption, and even some of the metadata is hidden, and this is to avoid ossification of the transport protocol. So the name QUIC might want to tell you that QUIC might be quicker or faster, and this is indeed the case. So if you, for example, want to request a website, you first have to do normally your TCP handshake, and then you have to do your TLS handshake, and then you do your HTTP request. But in QUIC, you combine both handshakes, so TCP and the TLS handshake are combined. So after already 1 round trip time, you can request your website and get the response. So in this talk, we're going to explore hypergiant deployments. So we should first have a first look at how those deployments look like. Hypergiants are just entities that contribute large shares of the internet traffic. So to handle these vast amounts of traffic they receive, they use multiple layers of load balancing. So the first opportunity to do so is using DNS. So if a user requests a DNS record, they will return them with an IP address, and usually they will return multiple IP addresses. But these IP addresses are virtual IP addresses, as we call them, because they are not used by just one host, but multiple hosts can respond for these IP addresses. Next, the user would use this IP address to connect to the infrastructure of the hypergiant, and within that infrastructure, there might be additional layers of load balancing. So first an ECMP, so for example, first ECMP load balancing, and then there might be layer 4 and layer 7 load balancers. The step from layer 4 to layer 7 load balancers is often handled using consistent hashing of the 5-tuple. So you use a hash of your source and destination, port and IP address, plus the transport protocol. And then according to this hash, always forward packets for the same connection to the same layer 7 load balancer. Throughout this talk, I will refer to on-net deployments as deployments within the autonomous system of a hypergiant, and to off-net deployments as deployments outside of the autonomous system of that hypergiant. So what has prior work done? Prior work has, for example, scanned the entire IPv4 address space, and this way you end up with a list of virtual IP addresses that are in use by given hypergiants. Additionally, you can also analyze how the DNS load balancing works, and you can use TLS certificates to fetch to detect offnet deployments. What we want to look into is the layer 7 load balances, so actually where the content is served from. And we want to do this with passive measurements, because passive measurements are non-intrusive. You just sit there, wait for data, and then you analyze it. And no one will know about it. So you can even analyze your competitors, and they will not know it because you don't send any additional traffic, nothing they can spot. And just to remind you, last year there was a request on the NNOC mailing list about active scanning of either all of the internet or large chunks of the internet for known vulnerabilities. And that one ended up soliciting a lot of responses. So maybe passive measurements are a good idea. So what did we want to achieve? Well, first we identify the servers of specific hypergiants. We do this simply using the IP to IS mapping. So then we know their ONNET deployments. Then we fingerprint these deployments to detect the same configurations in OFFNET servers. And then we, where possible, identify layer 7 load balances. So why is this interesting for the RIPE community? Well, with this additional information, you can understand why you see some unexpected traffic from your peers, or you can observe things like inter-domain replication between caches that you normally wouldn't want to have. So what is our approach? Well, we analyze QUIC backscatter traffic. We use QUIC because it's already broadly adopted by a lot of hypergiants. And for example, just to give you a number, in 2020, so already before the standardization, 75% of Facebook's traffic was QUIC. And QUIC gives us some additional information compared to UDP and TCP. And we want to use backscatter traffic because it is a passive measurement data source and relatively easy to capture. So just a quick refresher on what backscatter actually is. So backscatter is just response traffic to IP packets with incorrect source IP addresses. And in fact, you can see a drawing here on the left. So when an attacker sends an IP packet with a random source IP address, for example, 1.2.3.4 to a server, then the server will respond to that false IP address. And if that false IP address is in the range of your network telescope, the packet that the server sends will arrive at your network telescope, and then that's the backscatter. That's what we will analyze. And why would attackers want to do this? Well, it is to leverage state exhaustion. So depicted here is our measurement setup and the QUIC one RTT handshake. So each QUIC connection begins with an initial packet, and then the server responds with multiple packets to establish the connection. And that is exactly what we see at the network telescope. So the packets highlighted in red here is what we receive. And as you can see, if the client does not react, these packets are sent again. So that is also what we analyze. Additionally, we find that you can also observe some properties of the attackers. So for example, you learn the QUIC version they use to attack these servers. And we'll look into the first part about the server behavior just now. So we use data from a relatively large network telescope, which is the CADA/9 IPv4 network telescope. And we used data from January of 2022. And where required, we extended our data set using active QUIC scans, TLS scans, and DNS scans only where necessary. So let's start with something simple. Shown here is the arrival of packets for different QUIC connections at our network telescope. And what you can see is there are distinct patterns for different hypergiants on when you see a lot of packets. What this means is that that the servers that send those packets are similarly configured on when to send these packets. And if you look to the beginning of the graph, you can see when they start sending those packets. Then you can spot the intervals when they send a lot of packets are doubling each time. So you see there's an exponential backoff, and when you just count those peaks, you can find out how often they retransmit these packets. And as you have seen, that's a little bit different configured for each hypergiant. Next, we're going to look into the connection IDs. So QUIC during the handshake establishes connection IDs. There's one connection ID set by the server, and there's one connection ID set by the client. And we're going to look only into the server connection ID part, and we are going to look at them as their hexadecimal representation, just from left to right. And this is what is shown here. So on the x-axis of these graphs, you have the position in the SCID, and on the y-axis, you have how often we observe a certain value at those positions. And what you can first spot is Google and Facebook use the same length of SCIDs, while Cloudflare uses longer SCIDs. And you can also remark that at certain positions, some values are way more frequently used than at other positions. And what this means is that there's information encoded in there. And if you dig a little further, you can find that for Facebook, for example, the encoding is documented in their QUIC implementation, and you find what is encoded at which positions. So they encode a version, they encode a host ID, a worker ID, and a process ID. Next, we use this information that we learned, so we can, for example, detect off-net deployments of Cloudflare, because we know they always start with a 1 in the first byte. And for Facebook, we know that they all, at the time of our measurement, they only use version 1 of the SCID. So we also know the beginning of the SCID. And with this, we look into packets that receive from other autonomous systems. And this way, we are able to detect a lot of these servers already correctly, but we still have a higher false positive rate. This is the SCID row shown here. And additionally, we found that Facebook uses low host IDs for their off-net deployments. So we know that that the host ID always begins with a lot of zeros. So using this additional information, we find we can improve our classificators and detect the same amount of true positives and have way less false positives. So this is just a new way to detect off-net servers. So now that I have introduced you to the host ID, the question is, what does such a host ID denominate? Well, it denominates the QUIC endpoint. So that is, in this case, the layer 7 load balancer in the end of this graphic. And now the question arises, why would you want to encode such a host ID into the connection ID? And the answer is, for QUIC, you might have connection migration. So during an existing QUIC connection, the client can change its IP address, but the QUIC connection should be kept active. And when you do this with the setup, your 5-tuple changes, and so your requests would be forwarded to a different layer 7 load balancer, which would not have the state of the QUIC connection, so your QUIC connection would break. And to avoid this, you give the layer 4 load balancer the information on how to forward the packet properly, and this way it will arrive at the same load balancer instance as before, and your connection can be maintained. So next, we wanted to find out about Facebook's content serving infrastructure. So there we did some active probing. So we probed around 3,000 of Facebook's virtual IP addresses. We sent a lot of packets to each of them, and we alternated the source ports. So we would arrive at a lot of different host IDs, hopefully. And using this method, we end up with 37,000 different host IDs. Already 90% of these can be observed in our passive measurement data set. And next, we try to group multiple different virtual IP addresses into clusters. So that is the front-end cluster of Facebook. And we do this We group them only if multiple virtual IP addresses share the same host ID. So behind different virtual IP addresses, we observe the same host ID. And this way we find 115 Facebook clusters of about equal size. So they all consist, nearly all of them consist of 22 virtual IP addresses. We additionally found that all of these clusters just span a single /24 IP prefix. There's one exception to this rule. And we found that each host ID can answer requests for any of the virtual IP addresses in that cluster. So when you want to know the size of a cluster, described by the number of different host IDs in that cluster, you just have to scan one virtual IP address, and you know that all the other virtual IP addresses won't give you any more different host IDs. Next, we mapped the location of the clusters using IP address geolocation to different countries. And what we found is that in Asia, there are a lot more host IDs per cluster than in any other region. And at first we were surprised at this result, but we think that the reason for this is just the large population in that area, and that Facebook does not have that many data centers in that region. So now the question is, will this also work in the future? And we would answer this with a yes, because there will be no internet without attackers. And we think that even the backscatter will increase with more attackers adopting QUIC. So even more of our measurements can be done without active scanning. And to conclude my talk, we just saw that passive non-intrusive measurement data can tell us a lot about hypergiants. We used QUIC features that we saw to create fingerprints and to take off-net deployments. And otherwise, you saw that structured connection IDs are a good stateless solution on maintaining connections when the underlying file tuple might change. And if you want to read more about this, there's an internet draft currently at the IETF, so you can find more details. And they also do some encryption of the connection IDs, so your details don't leak to the public. And with that, I can refer you to our paper. You can find more details here, or you can ask questions now. Thank you for your attention.
Hello. Okay. Good morning, everyone. Do we have any questions? I didn't see any questions online so far. We don't seem to have any questions on the stage here in presence. Oh, one at the microphone. Thank you.
Two questions. Okay.
It's there first.
It's typical. Wait, maybe I'll give you my mic.
All right. Chris Woodfield, RNAC. Is there any indication that these VIP endpoints are unicast endpoints or anycasted?
They are, what do you mean with endpoints now? So the IP addresses are unicast.
The VIPs that were detected through this practice.
They're unicast.
Okay, unicast? All right, thank you.
Morning, I'm Lars Eggert. So this is a nice talk, thank you. I wonder if you had thoughts of how you would continue this study if you were going to continue it, because it seems like you've got to follow what the implementations are doing and what's being deployed pretty closely in order to understand the structure of the SIDS.
Yeah, we want to continue on this path, but currently I can't tell you any more details. But you might see some more papers in this direction later.
Give me a teaser.
I
mean, that's a very corporate answer right there. It's fine. Don't worry. Thank you.
Sorry.
We still have some time available for questions. Oh, there's one coming.
Anna from the University of Aberdeen. It looks like you've done the study for IPv4. Do you think it would be feasible over IPv6 as well?
Yes, so in principle, this approach should work with IPv6 just the same, but you have to have the same data, and I'm not aware of any large-scale IPv6 telescopes as of now. But if you can get any of this information, we would be happy to collaborate.
No one else? Okay, Dimitra, we have anyone online? Any question on Meetup?
Can say, because here.
Let me check. No, I don't see any. Okay, well, then thank you very much.
Thank you.
So while the next presenter prepares, I'll introduce him in a moment. Etienne, if you're in the room, we need your slides. Okay, perfect. Thank you. And in the meantime, let me ask you to rate the talks, please, at the end of the session. And okay, so the presenter we have right now is Claudio Allocchio, and we have a remote presenter.
Which should be online.
Which should be online. Hopefully. In a moment.
I do. Morning, everyone.
Morning, Fabio.
And Fabio Farina. They're both from the Italian NLnet, GARR. And I think, Claudio, do you need any help?
I should be online. Yeah. But I go with remote presentation from here. And then I just do the live later on. Or do you want me to do it from here, as you like?
It's up to them.
No, let's do it with the remote, and then I switch over.
Okay, so the floor is yours.
Okay, so thank you everyone for being with us this morning, especially after the dinner the evening before. I know how hard it is to be on time at the first session. So what are we going to do this morning? Well, the title of this presentation, which I will share with my colleague Fabio, which is there in Milan, is Monitor the Hidden Time Map. What do we mean by hidden? Well, normally, when let's try to make a comparison with a normal traffic pattern that we know most, the car one, the traffic one. So this is the outline of what we are going to do, why we created Time Map, what is in the current status, what are we doing now to go beyond the observation, and even further idea which are wondering about in the head of the group which we are working together. It's a group by the GEANT. GEANT is a European multinational big backbone which connects 44, I think, countries now, and covers all over Europe with connection everywhere. So what are we talking about? Well, when I take my car and I leave to go somewhere, especially if I need to go via a motorway or a city, what I normally do, I switch on my navigator and click on it and say, I want to go there. And then I start to look at the colors. How is the road going to be ahead? I did it yesterday because I had to go to the airport, and I wanted to know if the motorway exit to the airport was red as usual, so I should avoid it, or very green. It was very green, so I went straight to it. And I also want to know how it is in average anyhow, because when I do a monitoring system, I want to plan for the future. So if I need to do something between, for example, Italy and Estonia, and I know that I'm going to use that link for a very specific activity, I want to check if that link is very stable or had some hiccups and might create me some trouble if I do something live on it. And so the question is, well, if I listen to the radio and I get something like, okay, Highway 101 in California, 364 vehicles per minute, it may be very nice because it's a 6-lane motorway, fine, flow is going smoothly and so on, no traffic jam, etc. But the same number can be very bad if it is a narrow country road like this, and a lot of stops and go. So this is why we want to know in advance what is happening. And When I want to go somewhere, as I said, I want to look at the map and check if I have any red spot in front of me and try to avoid it, to go around it, etc., etc. I want to know also the transit times. So what do I want to measure in general in this case? Well, we normally measure bandwidth. This was, now I got a new one, this was my classical GARR backbone weather map, my national network. I see a lot of green, I'm happy. But what I am measuring here, well, here I am measuring bit per second, not how smooth they flow and not how fast they flow. I can be sure that if I need to send bits between Milan and Rome, I can do it quite smoothly, but how much time I'm going to take? And are they going to jitter a lot or not? I don't know. So that's why this part of the network monitoring, which we are monitoring now, is called the hidden part of the network monitoring, because nobody does it. So we decided to do it and to start. So there are real-time applications like this one. This is the most typical one that is affected by very bad network performances. Bad network performances that not means data losses, means a lot of latency and a lot of jitter. This is LoLa. LoLa is low latency audio video system. It's just a video conferencing system which requires to run very fast because the embedded latency of the system itself is 4 milliseconds. If you compare it to Zoom or whatever, which is 400 milliseconds, you can understand why having a network which is fast, very stable and reliable is important, because the network is an important piece of application like this. And so it tries to use the lowest possible round trip times along the network, and it must be very stable. And the reason for it is that it does not use any audio and video buffering. And the audio and video buffering, as you know, is a trick that things like Netflix or YouTube use quite a lot. I think you all know that when you watch a film on Netflix, you're watching 1.5 minutes late because of the buffering and so on. There is no buffering here. So the network must be stable, fast, and quick. So an application like this wants to set the speed control, then you just drive and you do nothing else and then go ahead. So how did we create this stuff? Well, just to let you know, these kind of applications are on the very fast rise. I mean, LoRa installation grew 32% in 1 year, and even more in the world, even more in Europe. As you can see, the red ones are the new ones. So it means that everywhere there is something like this, you need to be in control of the network latency and jitter. It is not only for audio and video, it is for real-time control of anything. I mean, there are some experiments which you want to do in real-time control, and you need latency as low as possible, and you need to be sure that the data flow in a very steady way and not in jumping and going ahead and coming back. So we created this object, which is called TimeMap. It is needed to do a live tracking, but it also has got historical things. But monitoring is not the only thing. I mean, one of the very well-known sentences in monitoring is, if you don't monitor, you don't control what you're doing. But you also need to know the history, as I said before. Then we saw the data and we decided to go beyond. And we decided to apply things like machine learning, alarms, and things that call automatically the network operator on people to fix some issues. I mean, it's nice to have a monitoring system, but normally you don't have a big screen and people standing there 24 hours per day watching it and say, ah, there is something strange. No, it's running behind the scene. And when there is something strange, beep, 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 alarm sound, and humans come into the scenery. So this means machine learning. This means a lot of authentication things and a lot of understanding of what is being done behind the scenes. So this is how we designed the system. The purpose of it was not yet to develop yet another piece of software that then needs a lot of maintenance, a lot of monitoring, a lot of updates, a lot of checking, etc. So we tried just to be an aggregator. We put together different things which already exist, which somebody else is maintaining. For example, for the graphical part, we decided we use Grafana. Somebody is taking care of having Grafana up to date, not we. So we put together the pieces. We did very little programming. That was one of the scope. Do not produce too much software code, because the more you produce, the more you have to maintain. And especially about everything, use standard specifications. When we started, of course, the idea was, oh, wonderful, we have TWAMP, as a monitoring protocol, which is a standard IETF one. Then we went around and discovered, well, how many vendors have actually implemented it? All. Oh, wonderful. Then we tried it, and then we discovered, yes, they implemented it, but it's a very early implementation stage. And so, for example, in JunoS, we found quite a lot of hiccups, and we had a lot of fixes by Juniper working with us to make it work. And it must be easy to deploy it and must have federated access control. Why federated access control? Well, I might decide that my monitoring data are not for everyone, but I want to authorize somebody to be able to see them, and not everybody, and so on. And it is very modular, containerized, etc. So a very state-of-the-art way of implement a software deployment in it. So this is how the architecture is done, but given that we have our main architect here, which is Fabio, I let Fabio go ahead and he will tell me when to switch over.
Thank you, Claudio. Well, as Claudio anticipated, TimeMap was focusing as a tool, not on developing new code, but on the data pipeline and the analysis of the data themselves. So when we decided how to implement TimeMap, the most natural choice was doing with an extract transform load pattern. Therefore, we figured out three main building blocks. Building a block that collects data from the devices using QUIC, as Claudio anticipated, and performs some kind of normalization. Then, of course, we need a time series database, and then we need all the upper layers that summarize the data and expose the data in an easy way towards the users, also granting access through the federated authentication and role-based access, multi-tenancy, and all the things that can keep control of the data. As I said, we focused on simplicity of deployment, so the very first choice was for today technologies doing towards Docker and containers world. So we wanted something that uses as most as possible off-the-shelf components, doing as little as code as possible, as Claudio said. Next slide, please. So how TimeMap is implemented, what's under the hood? Very simple components. We use the Influx and Grafana as building blocks for the central data lake. On top of that, we developed some thin layer of presentation using very, very simple HTML and JavaScript libraries for graph representation and visualization, together with the shibboleth layer to enable federated authentication. The only custom part in the very first release of TimeMap, of course, is the data acquisition. So again, we decided to go with something that leverages the very standard telemetry stack. So we decided to adopt Telegraph, and we implemented the custom Python code to get the SMP probes or QAMP measurements from the devices using some Python wrappers. Next slide, please. As the idea of TimeMap is the modularity, in the very first release, we were not relying on Influx and Grafana. We were using Elasticsearch and Kibana. But the plus of having such a simple framework architecture in general allowed us to switch from the Elastic stack to the Influx stack, because we realized that Elasticsearch had too large footprint for our needs. So we ended up in having more issues in running an Elasticsearch cluster than the problem that we were indeed able to solve by using that tool. And changing the engine was really simple, because again, we were focusing on the data pipelines, not on the technology themselves. Next one, please. Now I'm going to leave the stage again to Claudio, that because it's easier, that will show some screenshot and some interesting patterns that we noticed through TimeMap. Because one very interesting thing is that when you look at jitter and latency, you end up noticing a lot of things that are not related to jitter and latency, but to the overall health status of your network. Please, Claudio.
Thank you, Fabio. Well, for example, you can see that this is a screenshot which was taken by the GEANT backbone network map a few weeks ago, as this is also completely dynamic. I mean, the map itself is built from the ISIS routing data, so we don't do anything. When the network changes, the map changes. When we go live later on, you will see that the network is different because the network has been changing in the meantime. But let's use it as an example. I mean, what do you do? Well, here you still see an old version of it where RPM, which was the Juniper proprietary monitoring protocol, was still in use. And now we decided to decommit it completely because T1 is up and running in a decent way on Junipers, for example. So there's no more RPM. What do you do? Well, you have the map, you have the links, and you have the router. Very simple. You do a right click on the link or a right click on the router, and you get information out of it. And that is what you see. This is not the classical weather map. There's no color in here, even if we have the idea that we might add color when there is anomalies or so. But now you just go, for example, on a link, you click on it, and you get some data. Well, what do you get? Well, you also get a link on the router when you get anomalies. Anomaly detection is getting mature now, and so we decided to put it online. But I will show it later on live, this one. So what do you see? Well, very often you have some periodic events which happen during time over a link, and here you can see very easily there are spikes at a very regular time interval. What is that? Haha, we don't know. But we know that there is something we have to watch along that link. Why every few hours the latency and the jitter over that link get such a big spike? What is happening? And then you go and investigate and find out, and maybe you discover something that you need to fix on the network, or that you have some background process running that it is disturbing or creating the effect and so on. So this is very evident and very easy. You see them immediately. You immediately see rerouting, for example. If it is a circuit and not a fiber link, for example, you might have rerouting because you don't see how the data are flowing. But here you can see very easily that the latency is changing at regular intervals, going up and down, up and down. What is it? That's classical rerouting. You are going to go via different paths, so the latency changes. And given that with Grafana it's very easy to zoom into the data, you zoom in, and down there at the bottom, over 6 hours, you very clearly see that there are at least 3 paths along this link which you can take. A faster one, which was the first one, a slower one, which is the one in the middle, and the mid-range one, which is the one on the right. If you're doing something real time, this is a very bad situation because you never know what's going to happen to your data. And when the routing changes, you are going to have some issues in the data flow. We all know that everybody is relying on the NTP and more accurate stuff and so on. Well, this is what you see in a number of links. The above one is a very stable one. The clocks are very good in sync. The below one is not. There is drifting of the clocks, and that's very, very evident. They stay in average correct. But if you rely on the NTP on that link between these two locations, then you're wrong. Then you don't get the correct data. You are having such an important trend that you have to consider, and you need to use it in case you need to correct some data for synchronizing radio telescope or things like that. And that's the only way you can have it to make the correction. We have implemented the anomaly detection. Now, as you can see, the machine tries to learn what is happening, and when it is happening, then we have dots, and then human have to come in and try to understand what it is. Again, the machine is able to detect very easily the very big spikes, and the dots are all marked over there. some networks are starting to use ECMP, which is a very modern and very useful way to deploy the maximum power of the network itself, because you do multiple routing and multiple paths. Well, this is a typical pattern which happens when you use ECMP. As you can see, there is a slow path, a medium path, and a fast one, because there are 3 possible paths from A to B in this case. This is a typical pattern that you get when you use ECMP over a network, and you immediately see it. That's very, very clear. There are other things which we call not identified objects, not identified events. Well, actually, this one wasn't identified later on. This was something very strange happening over a link. And after that, we discovered that one of the interfaces were flipping, so the BGP routing was going up and down and changing all the time. And so we get the storm that you see over there. But this was a post-mortem analysis. We went to see it and we find it. This is another very strange thing which we are trying to investigate and to understand. As you can see, well, I can show it you better live later on. There is a very strange pattern in the latency, in the jitter, in the maximum values. They go up, 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 down, and then they correct down, and then down. And we discovered that it is a 24-hour pattern. What is it? I don't know. Maybe we have an answer to that. Maybe the router itself is doing some very strange maintenance, and we are discussing, for example, discuss with Juniper to find out exactly what is the cause of this. This was evident in a link which was very low traffic, so we saw it immediately. But when we made the analysis and we discovered it happens everywhere on the GEANT backbone, including on the heavy traffic ones. You just need to zoom on the lower part of the spectrum of the analysis, and you see it everywhere. So there is something we did not know at all before. Another very strange effect that we find out. These 2 routers, this link is 1.5 meters long, are 2 machines in the same rack. What is happening here? What is this solve pattern? We still don't have any idea. We are investigating together to try to understand why it happens. But it happens very regularly. So again, this is something which is not completely under control, and we need to find out. And now I leave to Fabio again, because this is the research part of it.
Yes, thank you again. Of course, having a look at the instantaneous data, the current data on anomaly detection, on latency indicator is helpful, and having an historical view of the trends helps in doing the analysis that Claudio showed us. But if you want to have a better way, a more modern way to perform network operation, having alert is a must-have today, because you do not want to stay looking at the data every second, but you want that the system itself has enough knowledge to provide information about what's going wrong. And this is in particular useful where you are preparing, for example, a LoLa session that needed careful tuning for a few days, and then in the nighttime something changes and your potential setup is disrupted. So you want to get information about things that changes in an unexpected way as soon as possible. So when we decided to introduce anomaly detection TimeMap, we did for this reason, and also we wanted to have one more tool to cross-correlate events that are not clear, because as you can imagine, jitter and latency have a wave front that propagates as effects. So everything is related during the all along the path all over the network. We wanted to have some strict requirement about the way we do machine learning. So as we have many flowing data and we do not have a priori knowledge about the quality of the data, we needed two kind of characteristics, two technical characteristics about the anomaly detection algorithms. We want to have real-time streaming machine learning algorithms. So we must be able to learn while we classify. And we want to have robust statistical estimators. And of course, we want to keep the light footprint principle that drives all the TimeMap development. Next slide, please. So for the choice of the tool, we decided to go with a streaming machine library in Python that's called River. And this library has a wide range of machine learning algorithms that relies on streaming. So you learn things as the data flow. And anomaly detection in the end is just a way to do classification over the standard deviation. In principle, is an unsupervised task, but it can become very sensible to the overfit when you do very long runs, and TimeMap is a long running service. So the main risk here is that at a certain point you will start learning anomalies as regular points. To avoid this, we decided to use not one algorithm, but two families of algorithms. One is half-space random trees, is a kind of classifier. And we paired it with a completely different machine learning technique that it's called support vector machine. And we tuned both the algorithm to be sensible around 3 sigma, but the outcome of each method is weighted in some sort of majority rule that's called bagging as a name in machine learning. So we decided that a point is indeed anomalous just when both the algorithm says, okay, that point is indeed strange. Next slide, please. As the overall streaming machine learning approach is lightweight in terms of memory footprint, we decided to do this kind of approach. We decided to train a model for each link that connects a pair of routers, because the models themselves are small. And this is something that we need because latency and jitter are inherently related to the length of the distance between the routers. So having one model that fits all the measurements was something that we do not like, because it would be too generic. We want to characterize exactly the behavior of each link. And from the technical point of view, the container that runs all the algorithms is just a bunch of Python lines. Everything is less than 300 lines of code that runs as a sidecar Docker container that talks to Influx. It pulls data. It runs every 5 minutes the classification and marks the data as anomalous if needed. Next slide, please. Well, this is the result of all these algorithms, just a pale dot on a bar chart. The next one. Where we are going with the evolution of the anomaly detection site, we would like to fix two issues that we are facing right now. We want to mitigate the problem of overfitting at constant trips. So we would like to have an algorithm that it's also able to forget things, not just to learn things, because forgetting is an important part of the intelligence. And we would like to have a method.
Here we have 1 minute.
Yeah, sorry. And I would like to have a method that marks when anomalies situation ends. We are exploring a number of different methods that are richer and could provide even more interesting things on this insight. Claudio.
So thank you. Well, all the links and all the thing that can be found here, the idea is that it's something that you can just download and go very quickly. And while we wait for take question, I put online the live demo, so we can even go and have a look to it while we take question. So we switch over to the other one. And let me see. Okay, well, you have a meanwhile, if you have any question, just come forward and ask. This is how it is. You need to authenticate, so I need to log in. I already put my password in. This is a map. I go on a link, for example, I don't know, this one, which is the one which I like a lot. Ask for the statistics. Of course, I need me to authenticate again. So let's go. Here we go. Grafana is collecting data. As you see, I also already see here some anomalies. I can select how long it is. Let's see, 24 hours. And as you can see, this is the example I was showing you before. Very strange things happening at night where we don't have an explanation. And if I want to see something like, for example, in here, I just go and zoom. And then I get the data and I can explore. Or if I go again on the map and I want to see anomalies in Amsterdam, there we go, now anomalies. And then I get all the list of the possible anomalies that the artificial intelligence algorithm has detected, and then I can go and investigate and so on. So questions, or there you are.
Hi, Alexandros Milodidakis from KTH. So in the past, I have also used anomaly detection to monitor collocation facilities and IXP links. The daily patterns that you show are quite common and they happen a lot. And if I understand correctly, at the end of the day, to deal with them, you actually mixed two algorithms together to get verification of when is the actual anomaly. I have one question to ask. Have you thought of like those anomalies that you said as daily patterns? They are not really anomalies, but have you thought of, if you consider those as anomalies, then identifying the real anomalies out of those anomalies? So you can put those anomalies to an algorithm to figure out the real deviations from the usual pattern.
Well, I think Fabio is more qualified than me to answer this, but
yeah, this is something that we are considering with the richer models. I mean, so far the algorithms that we chose were focusing mainly on the streaming approach. So we did not want to have a training phase as separate from the observation. For a better classification, of course, we will need some kind of training phase, or at least hyperparameter tunings to have a better insight of the distribution that are underlying the signals, because in the other we are talking about overlapping of different signal sources.
Yes, just be careful with the hyperparameter source. Like if you touch those values, you need to know exactly what you are doing, because they may work right now, but in the future they may start failing. So it's like, doesn't mean because it works now it will work in the future. So if you always touch those values, you need to figure if you do it like an automatic way for that to work.
Yeah, that's exactly what, for example, TimeMap does. It retrains periodically over the last 24 hours to really start from scratch in some sense. But it's not something that it's really satisfying. I mean, it's somehow a Windows approach, turn off and restart. It's not satisfying.
Yep, thank you. You can also use something longer than 24 hours because there may be other kind of deviation, but thank you very much.
Yeah.
Thank you for your suggestion.
Oh, sorry, quickly, please, we have a bit of time.
Hello, thank you very much for your presentation. My name is Alexander Azimov Yandex. I'm pretty sure that you are aware that WAMP is, of course, it's not a passive measurement, it's an active measurement that is generated using a CPU of the device that is making the measurement. I wonder if you have studied how the CPU usage of the device is affecting what you are seeing in the RTT measurements. Thank you.
Well, this is a thing that we are working on because, for example, one anomaly which I show might be exactly this. CPU is doing something and then it's affecting. And I know that some vendors are working to make it in firmware, so the problem disappears. It's very immature as an implementation in the machines, I should say. Cisco is even worse than Juniper in this moment for the implementation. But yes, it is. And of course, that is why we need to correlate this data with everything else. We are also connecting all the data from the machine, from the router itself. So we have CPU load, even temperature can affect it. So we are correlating all this data all together because that, of course, in that case, you discard immediately the fake anomalies because they are caused by something else. But the ones caused by something else are very regular. You see them all the time, while the real anomalies are not, because there is something happening really on the network.
Okay, thank you.
Thank you. Excellent. I'm amazed to have Fabio, Claudio, remote, local, and live presentation.
Thank you.
Does your TimeMap plugin work for people outside of the organization?
Yeah.
Great. Thank you very much.
And of course, this is intended to be installed by anybody who wants. It's an open source. You download it and
that's
you
a
run.
good thing.
Thank you.
Thank you a lot, guys. Please. Thank you, Fabio. All right, you can watch us. Thank you, Willem. Yeah, welcome. And Willem Toorop from NLnet Labs is talking about improvement. Thank you. It's about 10 minutes.
Yes, this is a presentation about route origin validation. So hence the capital ROV in improvement. And it's actually a presentation about a research project that Kevin Clark from the University of Amsterdam did with us at NLnet Labs. So me and Koen van Hoven supervised it. He did this in the context of his security and network engineering master. And well, earlier research has shown that if you have both a valid announcement and a RPKI invalid announcement of the same prefix or overlapping prefixes on the internet, then RPKI has a bit of a weakest link problem, in the sense that if an endpoint tries to contact the actual IP address on the valid announcement, any hop on the path that does not do route origin validation can redirect it to the invalid announcement. And so there's about it, so Koen van Hoven has actually done a really nice blog post on that very subject, which is on the RIPE Labs website. And what he did was he ran a RPKI certificate authority on both a valid and an invalid prefix. And RPKI validators, 25% of them reached the certificate authority running on the invalid. So even validating routers that are likely to be in RPKI validated resources can reach the invalid because of on-the-path hops. So the research question that Kevin asked himself is, can we determine what the most prominent hops are that redirect people to or redirect traffic to the invalid? And you know, which ASs have the most impact on redirecting traffic to invalid announced RPKI resource? That's basically the question. All right, and so his experiment consisted from doing 2 announcements. One valid announcement, announced anycasted across the 30 POPs that were available at the time of this research, the 10th of March this year. So it's a less specific valid announcement, /23, and then a more specific invalid announcement without a valid route origin attestation at Allocchio. I can tell you that invalid announcement goes everywhere from Allocchio. So even though the transit providers of Allocchio do not forward it, Allocchio has such good peering that it comes everywhere. By the way, so Allocchio is a organization of network hobbyists, so to say, in Amsterdam, and this is the invalid comes everywhere because they have really good connectivity. So very suitable for this kind of experiments. So on one of the addresses, which is in both the valid and the invalid announcement, address number 6, we run a authoritative name server that on the valid says, hooray, your resolver reached the RPKI valid announcement, and on the invalid says, no, your resolver reached the RPKI invalid announcement at Allocchio. Sorry. And also the valid announcement is larger, right? Because it's less specific. Also has another number that on which the authoritative name server is running, which always says, hooray, you reached the valid, because you know the invalid is not, there's no invalid announcement for that IP address. And so if you would reach the valid announcement from an endpoint on the internet, then that means that the trace route to the earlier part, which is also announced invalidly, and the second half, that is only allowed validly, are the same, right? So we don't actually know if all the hops on that trace route then do route origin validation. So some hops could not, but surrounded by other hops that do it, and therefore it reaches the valid. But what we can tell is if a trace route reaches the invalid, then the paths will diverge the trace routes. And we can also say that the hop that is just before the point where the paths diverged to the valid and invalid announcement is the hop that does not do route origin validation. So we, with the help of Emil Aben, submitted a few ripe atlas measurements, one DNS query to determine the baseline, which probes go to the invalid, which go to the invalid, and from all the probes on ripe atlas, do the 2 trace routes. And these are the results. So 43% of the IPv6 probes reach the invalid and 48 of IPv4. So IPv6 is slightly better. And from this graph, you can see that this is a graph showing the impact it would have if the ASs on the axis would do route origin validation. So from this graph, you can see that if 25 of the ASs that are on those paths that we detected that do not do route origin validation would do it, that would already be a 50% improvement for IPv4 and 60% improvement for IPv6. And so this was the most prominent AS to divert traffic to the invalid announcement. Is someone from Telecom Italia in the room, perhaps? No. would be good if you would do router region validation. We looked at where on which hop the redirection to the invalid took place. So hop number 7 on the trace route is most prominent, but you have to look, of course, at how that hop is relative to the path. And we looked at that, and that's remarkably almost a strange line. So it's not the first few hops that diverted to the invalid announcement, but it's pretty much spread all over the hops in all the trace routes. Furthermore, we also looked at which Anycast hop the probes would end up with when reaching the valid. And here we clearly see wipe atlas bias. So Frankfurt has, more than 20% of everything that reaches. So the colored piece is reaching the invalid. I think what is remarkable here is that there are some, or the probes that have affinity with some Anycast pops are more likely to reach the invalid than others. So the 3 conclusions from those graphs I just show you are: a small group of organizations can have a big impact on routing security. This can happen anywhere on the path, and some pops fare better than others. And that's more or less the presentation. So I'm open to questions. I have 57 seconds.
Okay, my microphone wasn't working. We have a question here in the front, and then we'll do one in the back. And
okay. Alexandros Milolidakis again from KTH. Have you checked the opposite of what you did? So if some ASs fail to do validation, what will happen? I'm asking because I have seen some weird stuff sometimes, so it will be interesting, the reverse of what you did.
So if hops that do now validate would not do it, what would happen then?
Yes.
Oh yeah, that's much more positive presentation.
I have seen something very interesting, that's why, and I can say that it happens sometimes.
Okay. Yes, that would be interesting, yes. So now we haven't looked at that in this research. No.
So now you know your next one.
Yes.
Peter Hessler, I'm wondering if you took a look at the ASs that were not doing origin validation and compared it to public announcements that, yes, this AS is doing public validation and is checking this and seeing if there's a discrepancy between those who claim they are and those who actually are not.
No, we haven't done that. This is, we just measured it and collected the numbers. Yeah.
Okay, thank you.
Yeah.
Okay, we've run out of time, so thank you very much.
You're welcome.
Now, next up is Etienne Khan, who's going to talk about VPNs and how to measure them.
All right, thanks for being here this early in the morning. Let's have some exercise. Raise of hands, please. Who of you uses streaming services like Netflix or Disney Plus? Yeah, lots of hands, right. And who's annoyed that other regions than the one you live in have more content or different content? Yeah, that's what I want to see. And finally, who knows about Geo-Unblocking VPNs? Who promise you to show this content? All right, still a few hands. And now most importantly, who knows how they do it? So I hope the hands are not being raised right now. In any case, this is what we'll discuss right now. So what happened? Well, I was in a different country and I downloaded a show onto my device and I was like, hey, it would be nice if I can finish watching the show when I get back home, right? So I booted up the Netflix app on my iPad or whatever device, and suddenly it says it's not available to watch in your area, and that I have to rather go back to the area I went to when I downloaded the show to keep on watching. So that's a bit annoying, right? But we're all network engineers here, and I can just set up my own VPN to that country I've been to. So I do that, and then Netflix gives me a different kind of message saying, hey, you're using a VPN or a proxy, and well, to fix the problem, please turn off the VPN. Okay, that's a bit rough, but I vaguely remember that some of these parties, like the one I'm showing right now, they told me, hey, if you use our VPN service, you can actually watch that kind of content. So I thought that's a bit strange. How are those VPN providers able to do so, whereas I, who set up the VPN, cannot? And that's how I got to my talk, Stranger VPNs. My name is Etienne Khan, and I'll be presenting this today. So I bought a trial subscription from one of the VPN providers, and I just thought, hey, let's do a trace route to see where we get to when we want to watch Netflix. And as you can see, that's already a pretty weird trace route to do if you are trying to look for Netflix. It's a single hop, and this address space we see is actually IETF protocol reserved. So we're off to a good start. It turns out though, so traceroute and ping and these things all don't work. They terminate here on this address after one hop. But we have found something very special in the Netflix CDN. So that's one of the URLs, for example. And when you just request the header of that CDN, you get a lot of text. And most of it is unimportant, but on the very bottom, you can actually see that our public IP address we have been requesting the header with is being shown in that header. So I thought, what will happen if I just request this through several VPN providers in several regions? So these are the VPN providers I was investigating, a small mix of smaller ones like WeVPN or Private VPN, and a few bigger ones doing all these commercials like NordVPN or ExpressVPN. Speaking of WeVPN, the one on the bottom, they actually went bankrupt apparently and took our money, so that's that. We had 2 measurement periods where we measured this IP header from these providers every 30 seconds. And we have one set of 4 million samples and another one of 7 million samples. And the samples we collected were pretty simple. So we have a Unix timestamp when we got that measurement, a status if everything was okay or not, and then the IP address we have detected doing the unblocking. So let's see how this actually looks so far. We are on the left, the VPN user, and we connect to the VPN provider gateway. When we try to resolve Netflix or any other site, we have to do, of course, a DNS request. And the DNS request gives us this weird IP, which actually is a TLS proxy. And from there, something weird happens, and then we get to the site. Because yes, after all, it does work. So this is actually what we measured, and we'll break it down to digest this more easily. Because this contains literally all of the information which is important. So for example, here we have the VPN provider CyberGhost for 3 different regions because they don't support unblocking in the Netherlands. And these graphs are split in 2 parts. Let's have a look at the top part. The top part shows how many unique IP addresses we found when looking for those unblocking IPs. Green color means IPv4, and the pink color, which we will see later, means IPv6. Also, this black bar on top on some of the graphs shows IP churn. So if the black bar is always riding the peaks of those, well, peaks of the IPs, it means we have always fresh IPs. Now switching to the bottom, that's actually a graph that shows to which AS those IP addresses belong. And the colors are accurate across all of the images. Meaning if you have, for example, the orange color here in the middle, that's only a single AS. But on the left side, there are many more ASs, or on the right side. And here we can see some very interesting patterns appear. For example, in the United States with CyberGhost, they've been using only a few IP addresses and a few ASs. And then in my second measurement period, roughly from August onwards, they started using a lot of ASs and roughly 2,200 different unique IPv4s per day for unblocking. By the way, we found more than 2,000 ASs, and we only gave the top 50 a unique color, and the rest were colored black. So if you see those black bars on the right side with the United States of CyberGhost, those are many, many ASs more. Here's a different pattern for ExpressVPN. You can especially see in the United States, they're relying only on IPv6 and apparently only on a few IPv6 addresses from a single AS. If we go to Japan, we see some weird patterns as well. For example, they're using one AS, the orange one, then for whatever reason decide to go into a whole mix of different ASs. And then at the end of September, they switched back to their one AS. But things can also look different like this. So this is Surfshark. They're apparently making use of only a single provider. And as you can see, the IP graph at the top shows that they're using a different IPv6 for every connection we requested. And the IP churn follows those lines perfectly, meaning that, well, we get a fresh IPv6 every time. Also interesting to see is on the right side in the United States, they have just a small mix of a few ASs they use for unblocking, let's say 2 or 3. But on some days, we have these dirty lines where there's suddenly a big amount of addresses rolling in, as well as some IPv4s. So I'm thinking that one of the engineers had made a mistake with configuring the unblocking on their side. And ultimately, we have private VPN, which has a bit of a special role because you can see the amount of IPs they use for unblocking is rather low, as well as the ASNs, and we'll discuss that a bit later. So this is how it looked so far, and actually we can split it up into different modes of operation. The first one is using specialized or hosting providers for the unblocking, and the second one, which many of you will find more interesting maybe, are residential proxies. Let's have a quick look at the top. So these were some of the nets that private VPN used, and you can see from the right maintainer object that they belong to instances that have a very similar name to private VPN, like private communication, Sverige AB, or PV, like private data net. And it turns out that these are all the same company run by private VPN. They created their own fake ISP, like Norisap, to look like they're a residential ISP, but in reality they're not. And also here we have PV Data Net. They claim to do dedicated hosting, but for some reason, since 2 years when I'm observing them, everything is coming soon, and all of the links just are dead links, like the one on the bottom right to Facebook and LinkedIn, whatever. We also found another weird party called Traffic Force from Lithuania. They supply a lot of the IPv6 addresses we've seen, and the only thing they say is that they provide unique solutions for global networks, and furthermore, you have to contact them and hope they reply to you. I guess if you throw a lot of money on the table to help you do the unblocking. Let's switch to a different type, the residential proxies. Here's just a small overview of ISPs we found in the 4 countries we measured. So we have all the big players like Deutsche Telekom in Germany, Vodafone or KPN in the Netherlands, well, NTT in Japan, and Comcast in America. On the right side, we show how many unique IP addresses we found for these providers. At this point, I also want to give a shout out to the Ministry of Defense, whose IP addresses we also found in our data set. And of course, we reported this to them immediately. We haven't heard back from them, but we've also not seen those IP addresses appear again. So I assume that's a good sign. So what have we seen today? Well, if you want to do unblocking, we first connect to the VPN server and get back this bogus host that's actually the TLS forwarding proxy. Then we get routed to one of the 2 different methods they use, the specialized hosting or fake ISPs, or the residential proxies, before we reach our ultimate goal, which is the streaming provider. So please talk to me if you have any more questions about the paper we wrote, or if you're a consumer or any kind of other ISP and actually want to help me in my follow-up study on this topic, or if you just want to talk. Thanks for your attention, and we still have some time for questions, I think.
Right, guys, any people who want to, I see you too. Okay, please, and that's it. Thank you for your insightful presentation.
Hi, Tim Mattenberg, DKX. Thank you very much. Very interesting stuff. I remember a couple of years ago, I basically was able to set such a DNS proxy up myself, and then at some point it stopped working because the upper path you showed was kind of detected by the cloud providers or the streaming providers. So I guess more stuff is happening on the lower path, the residential ISPs. Do you have any insight how do they get so many addresses in those networks? What's the benefit?
Yeah, so how they're getting them, I have some ideas and I talked to some people around here already. That's what I want to find out in my next study, so I can't really talk about this right now. But if you hear residential proxies, many of us probably think of botnets and malware, and I think it might go towards that direction, but I don't have concrete evidence right now.
Okay, and maybe just a second short question, do they also use those residential ISPs to actually tunnel all the traffic, or is it what I did back a couple of years ago, which is just the DNS requests and the rest of the traffic?
Yeah, so from what I see, it's just streaming sites. In some case, it might also be a news site for a site of a country where you need an IP address to see, let's say, all the content, but it's very difficult to verify because I would need to actually resolve all kind of domains against their resolver. I tried to do that for some sites, but it wasn't that fruitful.
Right.
So it's not all traffic, it's mostly the streaming.
Yeah, okay, thanks.
Please, next speaker, and introduce yourself.
Yeah, okay, so about this IP address from the Ministry of Defense that you saw, that makes me wonder whether if the customers of those VPN services that get routed through residential ISPs actually become endpoints themselves for other people who want to geo-unblock through their countries.
Yeah, thanks for the question. So there is some research on this topic, and it's some free VPNs that indeed do this. And I think Hola is one of those that comes to mind in this case. From the research I've read, the big players, let's say like Nord or ExpressVPN, their applications are actually clean. So they don't tunnel you back as a proxy, which makes us believe that their source is something else and not the actual VPN application. But for very shady, well, they're all shady, but for, let's say the free ones, that might be the case.
Thank you.
Thank you.
I think we are close to our limit, so thank you again, and it's very insightful. I guess when the VPN is a service, or Home Resolver the service will be next.
Yeah, thanks.
Keep research. Thank you. And with that, I introduce our last speaker, Tony Finch, talking about where time does come from. And by the way, folks, don't forget to rate the talks in the system. You can even win a cool prize. Thank you.
Okay, so where does my computer get the time from? Well, NTP. Here's a picture of an NTP packet. Here's a picture of David Mills, who invented NTP. So easy question, easy answer, end of presentation. Let's peel back a few layers and see where we go. So my Stratum 3 NTP servers get the time from Stratum 2 NTP servers, and Stratum 2 NTP servers get the time from Stratum 1 NTP servers, and they get the time from some reference clock. It might be a radio signal like MSF in the UK or DCF 77 in Germany, but most of the time it's going to be some GPS receiver. And they, of course, get the time from a GPS satellite. That's a picture up there. So where does GPS get the time from? Well, the GPS satellites are controlled from Schriever Space Force Base in Colorado. They do a lot of, look after a lot of super secret satellites, and you can see all of the different mission logos they've got there. It's a thoroughly ugly place with lots of security fences and things. But so where does Schriever Space Force Base get the time from? Well, in Colorado, on their site, they host the United States Naval Observatory Alternate Master Clock, and that is maintained by, thank you, the United States Naval Observatory in Washington, DC. So where does the USNO get its time from? Well, they have absolutely stacks of atomic clocks. They've got, you know, lots of cesium beam atomic clocks. They have hydrogen masers. They have rubidium fountain clocks. They have so many clocks that they have special buildings for housing their clocks. When I was preparing this talk, I was looking at the USNO, the USNO campus on in Washington, DC, and I saw this big scar. They've got a building site there. The accuracy of their clocks is affected to a large extent by the environment that they're held in, so stable temperature, stable humidity, and so they're building a new building just for even more atomic clocks. Now, there are a couple of other answers to this question, to where the USNO gets the time from. UTC is a kind of horrible compromise between atomic time and Earth rotation. So in order to keep the UTC in sync with Earth rotation, there is the International Earth Rotation Service, and every 6 months they send out Bulletin C, which says whether or not there is going to be a leap second in the next 6 months to keep UTC in sync with the rotation of the Earth. Now, the IERS is a big organization. They have multiple sites to carry out their scientific mission. And if you subscribe to their Bulletin A, which is every week, that tells you, it gives you detailed Earth orientation parameters. That will come from the United States Naval Observatory in Washington, DC. So obviously they need to know the precise orientation of the Earth underneath all of these GPS satellites so that you can get precise location from GPS. So there's a third answer. How does the US know that their atomic clocks are telling the right time? Well, they get the time from the International Bureau of Weights and Measures in Paris, and they are responsible for the official UTC. So where does the BIPM get official UTC from? Well, they have a periodical called Circular T, which includes the measurements from all of the time labs in national time labs all around the world. So NIST in Colorado, NPL in London, the observatory, the Paris Observatory, so on and so forth. And Circular T says how close each of these national time labs are to official UTC. So the next part of this is how is official UTC defined? Well, it's the BIPM is responsible for the International System of Units as defined by the General Conference of Weights and Measures, which is a treaty organization set up by the Convention of the Meter in 1875. The CGPM has defined, as part of the International System of Units, the exact frequency of atomic clocks based on the cesium atom. So where did this magic number, this 9.2 gigahertz number, come from? Well, it came from Louis Essen, who's that's Louis Essen, that's Jack Parry, who invented the cesium atomic clock in the 1950s. Now, where did they get the time from? How did they? I mean, they didn't know how fast their cesium clock ticked. They needed to calibrate it. And at that time, the definition of the second was based on astronomy. So they needed help from astronomers to calibrate their clock. And they got help from the United States Naval Observatory in Washington, DC. There's Bill Markowitz at the United States Naval Observatory, looked at the stars and measured the position of the Earth under the sky. And Louis Essen looked at his clock and measured the time that way. And they compared their measurements by also listening to the WWV time signal from the National Bureau of Standards in Washington. So where did Bill Markowitz get his definition of time from? Well, in 1952, the International Astronomical Union redefined the second from being based on the rotation of the Earth about its axis to what is called the ephemeris second, based on the orbit of the Earth around the Sun. Now, we had found out in the 1930s that the rotation of the Earth about its axis is not perfectly stable, not perfectly smooth, and clocks were getting better at keeping time than the Earth is. So where did this ephemeris second come from? Well, that's based on a model, a mathematical model of the solar system, which was created by Simon Newcomb in 1896 by collecting a huge amounts of astronomical data and building a mathematical model of the solar system. Here's a picture of Simon Newcomb. He's a fine Victorian gentleman. And where did he work? at the United States Naval Observatory in Washington, DC. So I think I've just about run out of layers to peel back now. I mean, before this point, time is all based on just looking at the stars and seeing them go past. But I guess there's another answer to my question. Where did my computer get the time from? Well, it does not get the time from the Royal Greenwich Observatory. And that's my talk.
Thank you, Tony. The cabal has been uncovered, and we meet. Right. Great. So you want to ask a quick one, or then announce, and that will be it. And then we have the general meeting part.
Stephen Strauss Fastly. So are you actually saying that the USNO are Time Lords, or?
Absolutely.
I only actually had one thing to add. The UTC is a weird standard, and as far as I remember, they have agreed, like at the General Conference on Weights and Measures, they've agreed to abolish leap seconds by 2035. I don't know if they specified what they will do with the drift away from UT1 or whatever the standard is, but leap seconds as a thing will stop bothering us at some point, is my understanding.
Hopefully, yes. Yeah, over the last couple of years, it's been a bit weird because the Earth has been rotating a bit faster than usual, and there's a risk of a negative leap second, which has never happened before, but the Earth has been slowing down again, so maybe it won't happen.
So just a separate leap second plenary next track meeting. It will be a big topic. Thank you, Tony. And with that, we are over, but the GM part has to be announced separately.
I had a question for Tony. It's Neil O'Reilly, right Vice Chair, and sometime stability analysis wonk. It seems to me that we've a system here that keeps on hanging together only because it keeps on hanging together. It's a bit like the importance of rotating inertia to the power grid. And I'm just wondering, how big, or indeed how scarily small, is the domain of attraction for the equilibrium that we sort of have?
Good question, don't know.
Great. And with that, we're done. Thank you everyone for being present here. It's astonishing attendance. And thanks to my co-moderator, Willem. Thank you.
So good morning, everyone. I think this is the moment that everybody is expecting. I have results from the general meeting for you. First of all, everything was roughly smooth. There were no major issues, so we have results and I can announce them. So let's go for that. Resolution number 1, the general meeting adopts the RIPE NCC financial report 2022, and there was majority voting yes, so the resolution is approved. Resolution number 2, the general meeting discharges the executive board with regards to its action as they appear from the annual report 2022 and financial report 2022. Again, supermajority of yes, so the resolution is approved. Now, resolution number 3. The general meeting adopts the RIPE NCC charging scheme 2024 model D. So that's a flat model with the lowest fees that were suggested by the board. Resolution number 4. In addition to the RIPE NCC charging scheme adopted in resolution 3, the general meeting adopts an extra charge of €50 per ASN as an integral part of the charging scheme 2024, and this resolution was not approved. Surprise, surprise, resolution number 5. In addition to the RIPE NCC charging scheme adopted in resolution 3, the general meeting adopts an extra charge of €500 per accepted transfer request as an integral part of the charging scheme 2024,
And again, the resolution is not approved. Resolution number 6, the general meeting adopts the amendments to the RIPE NCC Standard Service Agreement, and supermajority yes, resolution is approved. And now we have the elections. So I would like to thank all the candidates who participated. It was really brave, you know, to stand in front of you and say something. So thank you very much for that. And elected were Raymond, Maria, and Harald. Thank you very much and congratulations. And with that, I officially close the general meeting now. Thank you very much.
There we go. Right, good morning. Yes, it's still morning. Yes, it is indeed still morning. And welcome to the closing plenary session of RIPE 86. Thank you all for joining us. So I'm Brian Nisbet, this is Franziska Littler, who will be chairing this session. Remember, it's Franziska's last chairing of a session. Aww. More about that later. So just first off, just want to give you the results of the PC elections, and thank you for those. First of all, thank you for everyone who voted. It's very important to get the feedback from the community. Primarily, thank you to all of you who stood. It really is necessary to get new people in and move along, get new ideas. It's fantastic. We had a really good slate of candidates on this occasion. But the two people who have been elected are Doris Hauser and Clara Wade. So thank you very much.
Congratulations.
So onwards. So now we have our one presentation this morning. So Moritz Frenzel from Globalways. Yes, we'll be speaking to us about redesigning an out-of-band network for resilience. Thank you very much.
Okay, then thank you and good morning. Thank you all for coming after last night's social. A friend of mine recently called this session the feel-good session, and what feels better than having a resilient out-of-band network. So I'd just like to share a story. It's a bit inspired by the talk NTT previously gave about their OOB network. So this is just a show and tell. First off, who am I? As Brian mentioned, I'm the CEO of Globalways. I'm also vice chairman of the board at DNOG, network architect at Stuttgart IX. But most of this is actually just the concept I came up with. The implementation was by my lovely colleague Michael, who couldn't sadly make it to RIPE this time, but most of the credits belong to him. So quick one slide sales pitch, rather not, but just to give you a perspective of what it is we're talking about. Globalways is a more or less city network in Stuttgart, even though we have 360 kilometers of our own fiber with 700 connected buildings. We still operate even more devices all over Germany. And the main focus of this presentation is our 19 POPs, 15 of which are in Stuttgart, some in Frankfurt, Berlin, and Munich, and our core routers and PE routers, which we operate. Some important fact here is that everything in there is one IGP domain. So we basically, if the IGP goes down, we go down. So this is something we had to keep in mind when redesigning that OOB network. So in general, our OOB network, obviously it would be favorable to just buy a circuit from a random provider that is available nearby. But when operating a city network, you're most of the times alone in your POPs. And so in the old OOB network, what we did is basically we had this OOB stack, which I'll get into a second, which basically connected serial ports to our routers, and then had a layer 3 uplink that was going over our DWDM infrastructure, over then the triangles there are to symbolize EDFAs, and was then connected just to the next adjacent POP to somehow at least achieve redundancy in case something in that POP breaks. And then obviously we did this also in a more or less full mesh all around the network to achieve connectivity. The stack itself consisted of a Juniper switch, which basically was in place to handle or to convert copper to fiber. And then very modern Cisco 2509s with modern 10 megabit half duplex over AUI adapters. Who still runs these? I see enough hands. Okay, good old resilient stuff, but especially it's maybe time for an upgrade. And then to kind of give some smarts to the old stack, we just put a PC Engines APU 2 in there, running a custom Debian build to just be able to connect them via VPN and the like. As mentioned, we used the waves and where feasible circuits from other providers to connect them to the internet, and then used OpenVPN to a virtual and redundant concentrator, which was also running on Debian. So what issues did we have with this? First of all, 3RUs, especially in cramped city carrier cages where you most of the times can't grow beyond the rack, is a bit problematic. Also, the power draw with over 100 watts, more or less, this is a very conservative approach. It's more in the 150 watts was an issue. And since most of those POPs run on 84 volts, 48 volt DC, we also had to assign one fuse per device, which is also taking up quite some infrastructure. Then I guess everyone who already or who has once tried to run OpenVPN in a redundant way knows that failing over is not always reliable, quite a hassle to maintain, especially also to orchestrate. And if the VPN concentrator, even though being redundant, somehow fails, everything goes dark. The other issue we had is that the links to the other POPs also required working EDFAs, which can also fail. And as mentioned in the introduction, whenever we have a catastrophic IGP failure, which obviously shouldn't ever happen, we would also lose our out-of-band network, which is, I guess, the worst case scenario. So this is really the most pressing issue we wanted to fix. So yeah, we wanted to obviously reduce the footprint. We wanted to reduce the operational toll and mainly get rid of the VPN concentrator. We wanted to add multiple layers of resilience, and for that we choose to go via 3G, 4G, or 5G for sites where we couldn't get a second provider. As mentioned, this is the majority of the sites. And as an added bonus, we were looking into parameter security because those are not tier 3 data centers we're in, but rather tier 1 or, well, a better room somewhere in the train station. So having parameter security does help. We came up with, we then picked a device. We came up with this small open gear box I won't go into much detail about, but it has 4 serial ports and 4 USB ports, and you can use those USB ports to add even 4 more serial links where necessary. It has digital I/O ports we could use for the parameter security. It's Linux-based with full CLI access, and so you can actually install persistent binaries on that. And with just 11.5 watts of power consumption, we were actually in a very good shape. And I'll come in the summary to what that means in terms of money, but also in CO2 saved. Then for cellular connectivity, we had the issue that as most of our POPs are in train stations, therefore underground, not all POPs were available with the same mobile carrier. So we couldn't just go with, for example, Deutsche Telekom. We then found, after referral from the community, Wherever SIM, which is also available all over Europe, where you can basically buy one SIM and it books into whatever network is the strongest there. You have quite a lot of power there in controlling it. And it also offers data pooling, since most of our POPs are always available and we only need the cellular connectivity when it fails. It would be not feasible to buy a big data plan there in case something breaks, but rather buy one big data plan for the whole network and hope that we never have to use it. If necessary, it would offer IPsec and private APN, but this is nothing we wanted to go with. And then for the VPN. So we were generally in the market for evaluating a new VPN solution for us because after all, we are an ISP and not a VPN operator. And so we would rather focus our especially personal resources on running the network rather than running a VPN. And so given the current industry trends, especially at the time where we're evaluating this, WireGuard, especially in a full mesh configuration, sounded perfect. By having that full mesh with point-to-point connections, we removed the need for a concentrator, especially with the real fast speeds of kernel 5.6. This also seemed like an issue or a solution that could not only help us with the OOB network, but with our overall server fleet. And it has quite reduced complexity compared to OpenVPN. But even though key management is still a thing, commercial support at the time we were evaluating was not that present. We still need some sort of IP tables or NF tables to ACL everything. And to configure the full mesh, quite a lot of clever automation is required. Then again, we're an ISP, so we wanted to focus on not becoming a VPN operator. So for us, the solution was Tailscale, which basically uses WireGuard as a data plane, and Tailscale itself becomes the control plane, which means it magically builds the full mesh, especially only between devices that actually need to communicate together. It completely handles the key rotation for us. It removes the need for a firewall, as it just has simple JSON-based ACLs that are manageable via Git. And it's also completely audit compliant, which is a necessity, especially when you have to comply with multiple regulations. Obviously, yes, it does cost money. But ever since we switched to Tailscale for the entire company, we never had to worry about VPN since. And I can just recommend everyone who's especially running just a small network for themselves, give it a try. It's free for 3 users and 100 devices. And it will be so boring because you just install it and then everything just works and it's great. Obviously, yes, we rely on some cloud software, but it's been very resilient for the 2+ years we've been using it now. And they have great articles on their website explaining how they achieve that. The only main issue we face is with RFC 6598. For those who don't know it by heart, it's the CGNAT 100.64/10 prefix, which is used internally in Tailscale and which may cause some conflicts. And just last but not least, most of it is open source and actually also being audited by the community. So we do put quite some trust into that software. So then, putting it all together. Installing Tailscale on the OpenGear devices was fairly easy. It doesn't have kernel support. It's still running a 3.something kernel, but we don't need speed for out-of-band. 9,600 baud doesn't really require gigabit throughput on the kernel side. We just had to add a random APN for wherever sim to work. And then we basically just threw some Python and zero touch provisioning together. And actually, this is one of the few cases where zero touch actually just means taking it out of the box, plugging it in, and everything is installed, which also varies from hardware vendor to hardware vendor. And then obviously we wanted to build some monitoring for it. Sadly, it's still only SNMP, and I'm of the opinion that SNMP has served its time and we should be able to move on. But we've implemented everything in SNMP exporter, and we will add our configuration to the publicly available SNMP exporter generator.yaml, so you don't have to in the future. And there was a tweet by Freie last night about RFC 3021 that should be supported by everything by now. Sadly for OpenGear, that wasn't the case until a few months ago when we filed the bug, and now you can also just use /31 as a transfer network there. So yeah, you can see one of our deployments in Berlin there. It's just a very small device that can be mounted at the back of a rack unit and just throw in some cables and you're good to go. Sorry, that was the wrong button. So yeah, we have also a lot of insights with Grafana to see especially which radio is selected, what signal strength we have there, and also to see what changes here. And was really cool to see is the green bar at the very top, which just currently closed for the front and the back door. You can actually see when the door gets opened and for how long it was opened. So this is a very great way to verify your remote hands builds, and they don't like it if you do it. But yeah. So this was one of the few IT projects that just worked. Tailscale is amazing. Installing it in an OpenGear just worked, and wherever sim just worked. Also, having this fully meshed VPN is really amazing if especially you shoot yourself in the knee and your IGP goes down. Please don't ask me how I know, but it helps. As mentioned, the door contacts are very great for verifying your remote hands builds. Also, lesson learned that is ASR 1001 can crash when the remote hands kink the serial cable and produce a short. So please don't produce a short on your serial ports. It will crash multiple devices. We've tested it by now. Just a random advice here. And then, and I'm going to be completely honest, this was nothing we had in focus at the first, but reducing the power draw by 88.5 watts, as mentioned in the beginning, very conservatively, really adds up over time. So with roughly 1.7 kilowatts less, we saved 6.2 cents of CO2 per year. And this is also the 420 grams per kilowatt hour is a very conservative number. I don't want to try to push any greenwashing here, but just give you an idea of what replacing old and dated equipment, even though it works like those 2509 workhorses do, can have of environmental impact. But not only environmental, but also financial. With over 7,000 euro a year saved, the hardware break even for that project was in less than 3 years. So if everyone's looking for an argument to redo their OB network, it basically pays for itself by the time, or by 3 years time. So even before depreciation. For us, this mainly concludes the project for now, even though we still have some work to do. We're currently at 7 POPs rolled out, so we have 12 more to go. We want to open source the documentation for Tailscale and OpenGear, and will be available on our GitHub. We're currently cleaning up the SNMP exporter configuration, so it will be available in the Prometheus SNMP exporter Git. And maybe because we've written a console tool that allows you just to type console device name, and it will look it up in Netbox and just put a random SSH string together. If that's of interest to you, feel free to reach out, and we'll think about open sourcing it as well. So that's mainly it for the content. I'm a bit quick here, but this gives us more time for Q&A. If you want to join us for DNOG 15 in Berlin this year, at the end of the year, feel free to come over. And with that, I'll yield the floor to questions, and sorry for being so quick.
Thank you. Let's start at front mic.
Hello. Oh yeah, thank you. I will from NIMAG Networks. I'm wondering, because you were having APUs in your POPs, you know, you can put SIMs there, and you also can put USB serials there. Why didn't you just use them as improvement device and so on for your setup?
That's a really good remark. So mainly in the interest of time, because this requires a lot of implementation, especially getting LTE to work reliably on the Linux is an issue. Yeah.
Thank you.
Hello. Does each of those devices connect to a single mobile carrier or multiple mobile carriers? Do you need to have carrier redundancy?
The SIM card automatically switches to whichever signal is best, but you can change those settings in the interface of wherever SIM. So.
Okay. Have you ever had any problems with signal strength and reachability being unstable?
Not at all. They have all been available on the LTE band since we've installed them. But as mentioned, our initial site survey determined that this would have been a really bad issue. Would we have gone with just one carrier?
Yeah. Interesting. You've had better luck than I have. Thank you.
Okay, anyone else? I assume we don't have questions in the chat. Then, thank you, Moritz.
Thank you very much.
And next up, the RIPE 86 technical report.
Hello everyone, my name is Rob de Meester and I'm presenting you with the RIPE 86 technical report. So first let me introduce the team. I found out this morning that the morning after the RIPE dinner is not a great time to take a group photo. So Menno and Xavier are missing here. So we spent 3 days setting up this meeting. The truck arrived on Friday, and 1.5 hour. Well, we loaded the truck on Friday in Amsterdam, and 1.5 hours later, we started unpacking here. This is a small selection of the stuff we bring with us every meeting, and it took us 3 days to set up, and we hope to have everything packed 3 hours after this session. So first, a little something about the network. Looking at the logical topology, it looks a little like this, or rather like this. On the left, you can see all the networks that we operate. There's the main firewall, the DNS cluster, main router. All our servers are virtualized on 2 small Supermicro servers running VMware ESX8, and they're all deployed using Ansible. Physically, it looks like this, right behind that wall over there. We have XXLnet providing us with an uplink this time. We have a 10 gig backbone to various rooms. And on the picture, you can see the 2 Supermicros and the MikroTik switch on top of the cabinet. So throughout this floor alone, we placed 35 access points to guarantee a good connection everywhere. And there's a couple more on the second floor as well. As for the Wi-Fi network, we ran 3 different networks this time with 4 SSIDs. So we ran the main network on IPv6 mostly. And if you would like to know more about that, my colleague Andre wrote a very good RIPE Labs article about it, and he did a presentation about it last meeting. The RIPE MTG uses Yule, which is a translation tool between IPv4 and IPv6, and we have 256 IPv4 addresses available at this meeting. Last meeting, we became aware with some issues with, for example, NOS.nl, which is a Dutch news broadcaster, and some other video-on-demand platforms. And after many sleepless nights, my colleague Andre found that the problem was with Jules' default allocation strategy. And he contacted the developer, and the developer implemented a new allocation strategy over one weekend. And he called it the Andre Kaletka allocation strategy, which is nice. We have had reports this meeting that of problems with Cisco AnyConnect. We don't know why yet, but we'll try and figure it out between meetings. Like, we try to improve the network between every meeting. So with the main network running on IPv6 mostly, there is a little elephant in the room. So I mentioned the NOT64 network as also as a separate network this time. And that takes us back exactly 10 years into the past. In Dublin at RIPE 66, Marco Hogewoning, who was then the chair of the IPv6 working group, he asked after the tech report, this presentation, first of all, when are we running out of IPv4? And also he proposed the IPv6 only Wi-Fi network during the meetings. And it happened, the meeting afterwards, RIPE 67 in Athens, we had a IPv6 only network. Back then it had a very different technology behind it and a different SSID. Because since the last meeting in Belgrade, we run most of the main meeting network as IPv6 only, with v4 only served to legacy devices. So this means that the NOT64 network has become a little bit redundant, as it offers basically the same functionality as the meeting network. So, and here's an open question. Should we turn off the next NOT64 network for the next meeting and only keep the main network and the legacy network? Something to think about. Then a little something. Someone asked me this week how the presentation system we use works. And I realized it's been a while since we presented on it. So I'll do a short summary. We use two Mac Minis connected to an HDMI matrix switcher. It's a seamless switcher, so the signal doesn't drop when we switch. And this is important so that the projector doesn't start looking for a signal when we're switching. So we prepare the slides of the next presentation on the text on one of the Mac Minis there. And when the next presentation is up, we just switch the preset. We use a limit timer to show the clock through a presenter. It's on the stage here. It shows me I have 4 minutes left, so I'll hurry. We have an HDMI grabber, which MeetEcho uses to grab the output from the main screen to show it in the MeetEcho interface. And that way there's no delay on the clicker, while MeetEcho also gets the live displays directly from HDMI. And then to progress the slides, we use a DSUN clicker, which brings us to Wednesday. And the slides in both the main and side rooms looked like they were progressing by themselves, started living their own life a little. And we quickly realized that we bring two sets of clickers and the spare one. And of the main two we use, one of them is set to a custom channel, one of them is set to the default. But apparently we used the spare one and the one that's on the default. So they were interfering with each other. So we quickly unplugged the clicker in the side room, and from the test desk we progressed the slides. And during the break we set all the clickers to a different channel, so it doesn't matter now which one we use anymore. So if you're wondering how many engineers does it take to change the channel on a clicker, the answer is 6. So on Thursday morning, we had another little incident. The fire alarm went off, and luckily it turned out to be a technical malfunction in the building. But here's a nice graph where you can see the number of connections on our Wi-Fi dropping when people left the building and slowly getting back up again when it turned out to be a false alarm. Some quick statistics. This is a graph of the network traffic throughout the week. The first small peak you see is just the tech team setting up, and then the second one is the Monday all the way to today. You can see a little bit of this morning. Compared to the last meeting, we can see a big increase in devices that connect to our network using IPv6 only on the main network. And we think this is mostly to do with the fact that older devices are just slowly being replaced with newer phones and laptops. Coffee statistics, also very important. As you might remember, we had no barista in Belgrade due to COVID. And looking at this statistic, it might look like the numbers are up compared to Berlin, but if you divide it by the number of participants, it's actually less coffee per person was consumed during this meeting. Some statistics of the online participation, operating system usage seen in MeetEcho. Interesting that almost half of MeetEcho participants joined up over IPv6. And then there's a graph of the number of online participants on YouTube and MeetEcho. Of course, we don't have today's stat sheet. And yeah, that was it. I'd like to thank the web team, the MeetEcho team sitting behind the desk there as well, and of course the stenographers who did great work again. So thank you very much. And as always, if you have any questions, feel free to send us an email at ops@mtg or fill out the feedback form. So thank you. Any questions?
Jim Reed, just one of the many people come to write meetings. All I want to say is thank you very much to you and your colleagues for all the great work you've done. Because a lot of this stuff takes a huge amount of effort behind the scenes and we all just take it for granted. You've delivered an excellent network as usual. Thank you very much.
Thank you, Cynthia, Jim.
Okay, I'm going to go with the question we have in chat next. So from Sam van der Grub, what is the consideration for choosing ubiquity for Wi-Fi APs?
Actually, we used to use Arrowhive, and at some point a couple of meetings ago, we did half the network on Arrowhive, half the network on Ubiquity, and we asked people which gave you less problems, and well, the answer was then Ubiquity. So I think that's how it grew a little. Once they're up for replacement, we'll have another look at yeah, what we'll use, but for now these have just been working really well for us. So.
Okay, cool. Please.
Hi, Urban Srodolnik, Teograd. Thank you so much for an amazing network. I would just like to comment about the NAT64 network. I think it's really nice that when I'm here, I can test how it actually works. I think there is, I am an IPv6 enthusiast, but I don't have a chance to be in a NAT64 network only. And I think being at right meetings give me a chance to build trust in it and say, hey, we can implement this somewhere else. I have another request. It's an IPv6 only network without NAT64. Why? Because I want to see how things break. And maybe, so I think that maybe there will be other people interested here to see how that works. And I think that this is a great test bed, so to see in practice how things are and build trust or ask questions. Thank you.
Yeah, thank you. That's good feedback. That this is what we're looking for. So thank you.
Peter.
Peter Hessler, your question earlier about should we keep the NAT64 network, I think it was great for us to build up experience in testing and get it ready And now that the main network is IPv6 mostly and is essentially doing the same service, I think we could retire the NAT64 network. And then the suggestion from the commenter just before me of turning it into potentially an IPv6 only network would be fantastic and very interesting. As a comment, I occasionally do v6 only network deployments, and weird stuff breaks in very weird ways.
Yeah, that's what we are noticing as well sometimes. Yeah, thank you.
So we have just a couple of other comments. Okay, yeah, so Elvis Daniel Valea from V4 Escrow, just saying that everything was perfect from the online thing, apart from there was an echo for some remote participants. I'm not sure if that was their end or our end, but the comment was, yeah, there was some echo there. So.
Thank you.
And as he says, everything else was perfect, no loss, etc., all very good.
Thank you.
So yes, listen, thank you to you and the team and everybody for, again, another super smooth week. It's greatly appreciated. Thank you very much.
Thank you.
Okay, so now I'm not going to introduce Francisca. No, right, random switch at the last moment. So I'm going to introduce Cynthia Revström to give the update from, I think this is the first ever update from the Code of Conduct team. Thank you.
Yes. So as Brian just mentioned, yes, this is indeed the first ever transparency report from the Code of Conduct team, as it was set up just before this meeting. So we received 4 reports in total so far, 2 by email and 2 in person. 3 of them were resolved, 1 is still ongoing. And for each case, we formed assessment groups, considered if there were any conflict of interest, and if there were, the relevant people recused themselves. For each report, we also discussed the report with the reporting party, and if needed, we took further actions. We deliberated like what would need to be done and such. So the outcomes were just that 1 case was outside of our jurisdiction or responsibility. 1 case was passed to the PC, and they will remind the reported person about discipline during the microphone sessions. 1 case will be resolved between the 2 parties personally, and 1 case will be well, one case was discussed, and there was decided that no further action was needed. So just some more information about how to report. So you can report to the whole team by using the form or email, and you can also report to team members individually, either in person or by email individually. I think you can probably find our email addresses somewhere. Yeah, if not, I guess maybe ask us. I don't have that many slides today, but the call for volunteers is still open, and the chair team, I think, welcomes more people to nominate themselves. And there's a link there, and we can't fit it on the slide, but well, you can find the slides and click the link. Otherwise, I think you can probably find it using Google or another search engine. I do also want to point out, even if I don't have slides for it, that we did learn some lessons regarding that we really need to get some better tooling for next time to keep track of cases and well, how to also produce this transparency report and such. So it has been a good learning experience, and like, of course, we were never going to get everything right the first time. Although I think personally it went pretty well for having never done this before, and lots of it was because we got good training from Valerie Aurora, who did the Code of Conduct training for us, and yeah, I don't think there's that much more for me to say. But I'm happy to take questions if there are any.
Then, thank you, Cynthia. And maybe also a comment from my side. We also learned a lot about the whole process. So we will give probably an update over the next few meetings on what we want to change about the process, what we want to improve, and we also welcome your feedback on that. So we have one question in the chat. Carsten Schiefner. Hi, Carsten. What was the one outside the jurisdiction?
Well, we can't really report on or give that many details, but well,
okay, he says no details, just how and why. And I think what we can say about this is it was basically nothing on any right medium. It was somewhere else on social media, and this is just not covered by the code of conduct.
Yes, that's correct.
Daniel. Daniel needs a microphone. Oh,
Anyway, I'm Daniel. I'm speaking only for myself. I think you guys do something that is not fun, and you do it for the community, and I think you deserve a big round of applause for doing that.
Hi, thank you. Solo Stefan, what Daniel said.
Thank you.
Thank you.
And I don't think we have any more questions. And with that, I hand over this session to the chair team.
Thank you. And yeah, I'm super proud that we have this team in place. I think this is a great achievement for the by the community to have this process and this team now. And thank you very much for the transparency report. I think that's very useful for the community. So I think we're going to do this at the end of every meeting now. So fantastic. Right. So just now to the last part of the meeting, the closing plenary with some numbers and some prices. And yes, so I've just found out we had the biggest on-site attendance ever, which also explains the barista statistics, because we actually had more people here than ever before, more than in Berlin. So that's fantastic. You can see some numbers there, over 860 attendees on site and over 200 attendees online. Only 4 children in childcare, but I think they were very happy from what I heard, and the parents were very happy too that they could participate. So it's great. We also had almost 260 newcomers, which I've seen a lot of newcomers here during the week, and also there were also many online. By country, you see the on-site attendance by country. We had 60 people from 63 countries here represented. Obviously, most of them came from the Netherlands, which is great, because that's why we're moving the right meetings around. So to allow people to participate that maybe can't travel otherwise. And here are the same statistics for online participation. And there you see even more distribution, more countries, and from a number of more countries participated. I have another slide here for to thank the Code of Conduct team, just so we get used to their faces also, and that you know how to contact next time. Thanks again. Also, thank you to the outgoing working group chairs. We had Job Snijders and Sanders from routing working group and IoT working group respectively, who served a long time as co-chairs for their respective working groups. So thank them for their work. And here are the 2 new working group chairs, Ben for the routing working group and Peter for the IoT working group. So welcome to the team. And now this makes the whole working group chairs team here, all the faces on one page. And thank you all the working group chairs for providing such a good content and discussions during the working group sessions the last 2 days. Do you want to jump in there, Martin?
Mike, okay. Let's just say you forgot to mention that Andre Philipp also was an outgoing working group chair on the open source working group.
I thought he was going to step down next time, but
no,
yes, he announced it this time,
yes.
and because your terms I think say they didn't, but fair enough. Andre announced that he will step down from the open source working group, and the announcement for the call for nominations will be issued before the next meeting. So you'll still keep an eye on things, I'm sure, in the meantime. But thank you, Andre. You'll be on the slides next time. That brings me to the program committee. This is the this was the set of program committee members that were responsible for this week's meeting agenda for the plenary. You just heard, the elections for the new PC members. Thank you very much for the fantastic content. As usually, we actually have some gifts for you. Do you want to come up and get your gifts now? Alex is approaching the stage.
Wolfgang wants the gifts anyway, so.
And while you're handing out the gifts, I want to give a special thanks to the outgoing PC members, and especially Franziska, who has been a fantastic chair of the PC for the last 3 terms. So her number of terms ends here, and she's really run a tight ship with the program committee. I think it's great to see there's so many new submissions came in, and the working morale of the PC has been great under Franziska's leadership, so to speak. So thanks, Franziska, and also. And we're very lucky that she found another important role in the community to fulfill. So she won't get bored, and we will have enough interaction with her in the future, I'm sure. And also, of course, thanks to Milad, who's also stepping down from the PC, whose terms end this time. And yes, thank you. And welcome the two new elected PC members, Clara and Doris. They've been announced earlier in the session, so they will be part of the team before the next meeting. So, and more prizes and winners, and so there is a prize for the rating the presentations during the week. So we have 2 winners. We're not gonna, you don't have to come up to on stage this time. We'll you can come to the registration desk to pick up your presents. So there's Olivier Bengozi and Kerstin Enders, who have won prizes for rating the talks. So it is definitely worth rating the talks, not just to provide feedback, of course, to the PC and the working group chairs, but also to possibly win a prize. There are more prizes. There's a registration raffle prize, and the newcomers on-site registration prize goes to Sam van der Groep, and the newcomers online registration prize goes to Cliff Tam. So congratulations. And you can also win the prize for filling in the feedback form. So we're really trying to invite you to give us, rate the talks, give us feedback. You can win something. But even if you're not interested in the prizes, we're really grateful if you could fill in the feedback form, because that'll give us something to go on for next time. And more prizes to come. The WebNCC survey has been announced during the week, the survey for 2023. And there were 2 prizes that were announced. One is for the first, the people who filled in the survey during the first week that was issued. That goes to Aptekin Suneci. Is he here? No? Okay. And then there's also a prize to the person who filled in the survey during this week, and that goes to Kurt Kaiser, and he is here. I think they want to have a picture. Yeah. Okay. Oh. Yes, thank you. To promote the, filling in the survey, you can still do that, of course. And in case you missed anything about the presentations because you were, engaging with your colleagues here in the hallways maybe, there's of course the archives, the presentations and the recordings are already all uploaded. You can find them online. And there's also a daily meeting blog that the colleagues from the VIPE NCC are keeping up to date every day, and that's actually quite a fun read and a nice summary of what's happening. You might have noticed if you flipped all the way to the end of your badge, there was this VIPE 86 bingo, which was great fun, and quite a number of you have actually handed it in. And if you flip that around, it says, please recycle your badge. So please do that when you head out. There are some jars at the registration desk where you can drop in your badge and we can properly recycle them. Now, of course, this wouldn't be possible without our sponsors. So thanks again for everybody who sponsored the meeting and made it possible, and for all of us to cover the costs for the meetings here. And if you want to be on the slides for the next few meetings, one of the next few meetings, we have issued a call for hosts for the meeting 89, 90, and 91. And we already had some interest during the week, which is fantastic. And that's the whole point of having the call issued just before the meeting. So you can actually talk to you while you're here. But obviously, this is still open. So until mid-June, you can still contact us if you're interested to host one of those future meetings. We haven't made any decisions yet, so it's still very much open. And the next meeting has actually been agreed and announced, and we have a wonderful picture here that we took last night on the boat. It's Fabio Luciani from Namex and Hans-Peter Holland from the VIPE NCC, who have agreed to, Namex has agreed to host a meeting in Rome next time. Thank you very much, Namex. I'm really looking forward to going back to Rome. We've been there sometime. And yes, so unfortunately, Flavio couldn't be here, so I just put him on the slide and on the picture. And yeah, see you next time in Rome, and that ends the meeting. So bye, everyone.
As they say, well, this is awkward. So there was this thing once upon a time called the secret working group. And then the plenary, by accident, I assume, made this a formally accepted working group by accidentally going through the process of accepting a working group. So, welcome to, okay, this is going to take some effort, the public working group. Miriam, you are in so much trouble. We'll talk about that later. So, as working groups go. Oh yeah, I'm going to need a glass of water. Thank you. So, of course, we're just going to follow the format of a regular working group for now on. So there's the agenda bashing, then there's the housekeeping. Of course, there's a chair selection process that we need to talk about. There's the mailing list, and then probably some AOB. Don't think anyone has anything for the agenda. Please don't run to a microphone because I will ignore you. Then on to housekeeping, scribe. I don't think that's wise, to be honest. There's minutes from the previous session, and do not forget to rate the talks, obviously. So with that, let's go to the minutes from the last meeting, obviously redacted. Anyone, any questions? No, and then I think the minutes of Rep 85 are accepted. Then on to the chair selection process. There's one thing missing from the slide is how do we unappoint and how do we do the cycle? We'll change chairs whenever we feel like it. And the selection process is by a show of hands in the room. I mean, we could have done a humming because apparently that's popular, but it's Friday and we've all had a rough week. So I know I don't have much of a voice left. So, you know, without further ado, here's the 3 candidates. So from left to right, show of hands for number 1. Okay, that's roughly, it's roughly 10, I think. Number 2. All right, and finally number 3. You are smart people. So next right meeting, we'll have the room filled with these. You're welcome. Now, on to the mailing list. So this is a bit of a contentious thing, right? So usually there's a name-wg@ripe.net for mailing lists, but really, no. I mean, I'm happy to take this joke only so far, right? The secret working group doesn't really take those demands seriously, and we do not want to subsume under the RIPE domain because, as everyone knows, RIPE is actually part of the secret working group. It's not the other way around. So with that, if you want it like that, you can get it like that. So please do any submissions to ripe@secretworkinggroup.org, which is not a public mailing list for all the right reasons. Yes, it is available on IPv6. You are welcome. With that, this is, of course, my favorite slide ever. Oh, but really, welcome to the secret working group, RIPE 86 in Rotterdam. So what is the secret working group? We are here and we look at things and we observe things and we write things down and we comment on things. With that said, this session has a policy of no pictures, no Facebook, no Twitter, no Instagram, no Snapchat, no WhatsApp, and of course, definitely no Splat. And probably for the last time, what is Splat? That's a secret. Right, on to the main event. Okay, computer, Jan.
AI. Now it works. In a realm where AI creates, a logo was mandated, no debates. With pixels so precise, it caught all the eyes. AI's artistry boldly showcased its traits.
So this community in this meeting has a bit of a budding problem. We had a buff about the virtual elephant in the room, which is AI. And we're actually going to face problems with AI generated content invading these meetings going forward. Like this limerick, which was made by ChatGPT. So from this point on, we're mandating that every AI generated content being used at a RIPE meeting will be properly marked by this logo. As such, Red Sock as a service.
Red Sock as a service. In the laundry, RIPE made quite a gaffe, adding color where whites should be half. A red sock slipped the scene, turned the whites pink and mean. Now the clothes wear a rosy scarf.
If you're kind of wondering what this is about, you've never done laundry in your life. I mean, this is sort of the image of where this is going wrong. And if you've had a look at the meeting t-shirt, you see that the RIPE NCC has kindly taken care of this for you. So you don't have to worry about accidentally mixing a red sock with your ripe shirt. So there you go. It's a lovely color, isn't it? Right. And as the people from this building told us 20 minutes after we all got back inside, we do apologize for the inconvenience. This is, of course, about the fire alarm, where the stenographers helped us all out by telling us exactly what to do. So thank you very much, stenographers. You go above and beyond your duty here. I also like how they added the false alarm to the transcript, because that's for future reference is very relevant. Which also, I can't help but wonder what the transcript would have looked like if it hadn't been a false alarm. I don't know. And then there's an external submission to the secret working group. So I'm going to look in that general direction and expect someone to come up. Splat. Oh, it's Will. Okay.
We'll go up. Okay.
I guess you know how this thing works, right? Okay,
yeah, I think so.
Yeah.
Bye-bye. Those people, it seems to be, hello there. It seems to be an habit that some people are pushed to the stage. Like, in contrast to these people, I was pushed here by fluffy cat unicorns with a lot of glitter around. And they do absolutely amazing marketing slides. And so beside that, they also have been working in the past year to bring you the future of social networking. And obviously the marketing team went for the roots with no encryption and no blockchain and the best and reliable long-lasting system in the world. And so we had some community-driven team that understood the idea, and they obviously went to get some high-quality content. And so that was pushed up on some other random network. Yeah, well, things happened there. And so, all that was pushed the marketing team to also create some Japanese poetry. Like with a relationship between two lovers, two funny entities. And yet another joke, the splat takes a bit of space. The secret working group called, oh dear, what they did. From their smoke-filled backrooms, they spawned some voices from the void. And so, yeah, I don't have any answer to give you because I was not allowed to do that. And obviously, I don't know anything about it. So we might all see you at the next ride or not.
So thanks, Will, for forcing me to build a new slide at the part of the opening deck for next time. Well, but really, there's a bit of a takeaway here. And this is for the IPv6 working group. You need to take good notice of this. So Splat, I looked it up, first appeared in a presentation at the end of RIPE 77 in October 2018. And everyone was curious what it was, like really, really curious. So a good 5 years, not even 5 years later. And well, Splat now exists, terrifying, and people want it. And I think the takeaway message here is if you really want people to want something, you should tell them about something they can't have, and not that they're dumb if they don't have it. Now, this is a bit of a special secret working group because we don't have one, we have two sonnets this time. And this is a sonnet which is about 0.01 times War and Peace in length. Rounding error, I guess. And it's called Board as a Service. In realms of leadership, a void appears as Christian Kaufmann bids his fond adieu. From NCC's executive board, with tears, his departure leaves a challenge to pursue. With wisdom and resolve, he took the helm, guiding the organization with great care, his vision like a beacon, overwhelmed, inspiring colleagues in their cross to bear. His tireless dedication, steadfast grace, a testament to leadership untold. His departure, though bittersweet embrace, leaving memories and stories to be retold. Farewell, Christian Kaufmann, strong and true. Your legacy will endure. We thank you.
Generated by ChatGPT.
It's 100% true. So, I mean, not to be outdone, there's also a board as a service part deux. So we had a general meeting on Wednesday, which the current chairman, Andre, was super excited to chair, and he posted that on Twitter. Which is, I mean, a picture of the board all sitting there on Andre. I mean, it's lovely. I mean, it was a bit of an unfortunate picture moment for one of the board members who was sort of looking at the agenda, things to come. Then on to another sonnet. How do you like my video backgrounds, by the way? It's 2023. I thought I'd spice up the slides a little bit. It does blow up the size of your presentation quite a lot, though. Charge. And for that, we have our resident British person to actually do a proper job reading out the sonnet. So, Nigel, can we hear you?
I'm here. Yeah, can you hear me?
Excellent. Yes. So, off you go, Nigel.
Summer in the city. Not that I was there, of course, but there we go. It's Rotterdam again. Oh, joy, we cry. But right for this time is miles away by train. A very rare bright sun hangs in the sky, and not the usual miserable rain. But just in case, the social underground was hidden from all sight of missiles launched by members as new charging schemes abound, and ancient arguments with wounds unstaunched should lead to warfare twixt the small and large, each one complaining that they pay too much or not enough, or something different charged, or weird rules making sense just to the Dutch. I'm sure we've been here once or twice before. The whole thing's starting to be quite a bore.
Now for something completely different. Are you sick of RPKI? I'm sick of RPKI. And therefore, it is time for a revolt. No route sign, freedom to routes. We've had enough of RPKI. Really, it fills up the agenda in every part and corner. And really, the routes on the internet, they just need to be free. It is unfair for routes to be changed and locked behind keys. So keys are bad, and my table should be unchained. So with that, we have the No Routes Signed initiative. No Routes Signed is a global for-profit, obviously, organization that campaigns, empowers, and supports businesses to own the fundamental elements of their network routing. IP routes, the very fundamental elements of your network, are not owned by you or your business. In reality, the ownership and distribution of these routes lies in the hands of certain groups of nefarious policy specialists across the globe. And the NRS believes that everyone should use any internet route they like, even if they are scenic, and that communities are something you should drive through at speed. NRS helps enable network owners to control the future of their internet routing by educating them more on their BGP table. And join us at the obviously unencrypted nrs.lol. And then there was a dinner, and it was a good dinner. And you can always tell if it's a good dinner from the pictures that are taken. And we got a submission of a group picture that was taken after dinner. And it must have been a very, very, very good dinner.
At least for a photographer.
I mean, with modern cell phones, it takes quite an effort to make a picture like this, I think. And then there's another submission, which is a piece of secret content. And I mean, scan this. I'll give you 20, 30 seconds. I have no idea what it is, but I mean, this could be a social engineering hack, right? I mean, you've all heard of cybersecurity, I hope, at this point, maybe. Oh, no, I didn't say cameras are not allowed. Pay attention. And so I'm going to end, and this slide is apparently outdated, but I mean, it was a bit of a last second edition, I guess. See you in Redacted. See you next time. Bye.
Thank you very much.